Hello and welcome to this video presentation on augmented reality software that we're going to be using for this lesson. Now in this software we use an Aero. That's the name of the software. And what's going to happen is this relay control panel is going to be superimposed, going to have these superimposed buttons on it. And when a technician clicks on one of these buttons, then it'll reveal a circuit and it would talk with audio about how the circuit operates so it can help them with their troubleshooting. Now this is how they will get set up with this program. What they're going to do is, we'll show you, we're going to share a QR code when I click share, and it's going to come up with a QR code, then they'll scan the QR code on their iPad. Once the program starts up on their iPad, it's going to tell them to locate this panel. Now these superimposed buttons won't be shown until they locate the panel. And so that's what this video that I'm going to show you after this one, you will see that in action. So what's going to happen is these boxes is going to show up as if they actually own the panel. And so a technician can go up there and they can click on different boxes to learn more about the different circuits that make the lift doors operate. So these buttons, they stand for different things. So let's run through them right quick before I give you a little demonstration, and then you can get into the video. So this is door potential relay. So this relay right here just shows, a schematic diagram of different devices that are needed to get ready to make the door start. This one is responsible for closing the doors. This one has a circuit responsible for opening the doors. These two right here are responsible for applying DC braking to make the doors slow down when they open or closing. These two are the floor relays. So on the first floor, this relay will be energized, and on the fourth floor, this one will be energized. These two right here are safety circuits. When you click these, they show the circuits that are involved when the doors are closing and opening. So if something gets in between the doors, then there's a sensor that can detect that, and it'll make the doors open back up. These are just timer relays right here that helps the motor run a certain amount of time. Then you have these three right here that they control from a programmable logic controller. And then you have, this is a closed door relay. This relay right here causes the doors to open back up if there's a problem with the safety circuit. This right here controls the motors that actually opens the doors. And then this right here is the motor reset protection circuit. And here's another open door relay. Okay, so let's get into it. So I'm going to give you a preview of this, and then we're going to simulate what's going on with it when the technician actually has the iPad. So to simulate it, you have to click on preview. So what happens here is when I click one of these buttons, then the schematic is going to come up, and it's going to show something about that circuit, then it's going to say something about the audio. So let's just click on the safety edge. SEB door safety edge switch circuit. This circuit is responsible for detecting if there is something in between the doors when they are closed. Here's the circuit operation. RS line 118 must be energized. Depending on which floor the lift is at, the floor limits switch will be energized and will provide power to the step-down transformers in line 141. Power flows through a 2-amp fuse, through the door safety edge, back through a resistor, then returns to the transformer. When the doors close, pressure switches inside the rubber on the door seals were energized, and contacts will report to the PLC lines 150 and 151, depending on the floor the lift is at, that the doors are closed completely. Remember, if there is a closed operation and something is in between the doors, SET or SEB will not be energized and will constitute a fault causing relay L to reopen the doors as a safety mechanism. Okay, so each one of these will come up with audio and a circuit diagram to help the technician. So now let's get out of the preview mode and let me show you, because you're going to see this in the video. But when you click share, what happens is, see this QR code comes up there. And then what they have to do is scan this with their iPad. Once they scan this with their iPad, then it's going to tell them to locate the panel. Once they locate the panel, then those superimposed buttons are going to show up on there. Okay, so let me end this video here, and I want you to watch the main video. This is the program, and it's on Adobe Aero. And when I click over the preview, it's going to show you what the person will see that's going to be holding the iPad. Now, all of these different buttons and stuff, when they click on these buttons, they're going to bring up a schematic for each relay. So what this doing is just simulating what it's going to look like on the iPad, and then we're going to actually go through it. Okay, so I'm only going to do like 3 buttons because it's so many it'll take a long time to do it. Okay, so here we go. In this preview. So this is what the technician will see. All these right here, and then depending on what relay that it is, then he can click on it and then it'll bring up the schematic right there. Auxiliary and door braking circuit. This circuit provides timing for the DC door braking and the final application of power. And then it's got audio to go along with it. Circuit operation. When the door is near the seal, the open limit switch is open and relays OD, TD, and DL are de-energized. Relay DL de-energizes immediately and de-energizes DP, cutting off. Okay, and so that's just an example of one of them. It's probably gonna be about 2-3 minutes long. Then let me click on another one. Let's see, we'll click on this one. Let's see, we gotta go to preview, and then we'll click on this one. SET/SEB door safety edge switch circuit. This circuit is responsible for detecting if there is something in between the doors when they are closed. Here's the circuit operation. RS line 118. Okay, and then we're gonna do one more. We'll do CD. Okay, let's see, we gotta go back to preview, and then we'll do CD. Closing circuit. This circuit is the first circuit energized when a door close request is obtained from the PLC CR110 doors close request, line 170. Here's the circuit operation. RS must be energized, and depending on which floor, 1F1 or 2F1 contacts from floor relays, 1F or 2F back to the other screen. Energization. Then I give you a break. The closed limit switch relay CD, line 135, must be energized based on the limit switch position of the doors, line 133 and line 135, and there must be no fault at the door seals. Relay SEB and SET must not be energized. And CR110 close request line 170 should be energized from the PLC and must remain energized until the door has stopped moving. Remember, C7 closing contacts from the closing relay will energize relay M, which is the motor protection time delay relay, which will start M to timing, and the motors will have about a minute to operate until RS is de-energizing, causing all power to be removed from the door motors. Okay, so I just wanted to see how it goes back when each one of the prints come up there. They're gonna stay up there until the audio finishes, and then they go back to the regular screen. Okay, so now what I'm gonna do is I'm gonna let her take a break, and I got to get set up for making a little QR code so it can be scanned so we can look at it on the iPad. Okay, so we'll hit the pause there. Okay, we're back again. Now I'm gonna show how I'm gonna send this prototype to the iPad, and then I'm gonna do it with the iPad To facilitate the time though, we only just gonna click on like one or two of the superimposed buttons. Okay, so I go up here to the corner and I click share. Then it gives me this QR code right here. Then I'm gonna take my iPad and I'm gonna scan that QR code. Let's see. With my camera. Yeah, let's see. Okay, I'm gonna click open. And then while that's opening, since I'm not actually at the panel, let's see. I got my other iPad here. I want to demonstrate. But once it finds this image right here, then okay, let's continue. Okay, it's gonna tell me to locate this image. Okay, I got everything loaded up on the iPad. So the technician will take the iPad out to the work area. Once he line the iPad up with the picture of with the actual device, because I don't have it right here. All I got is a picture of it right here. But when he's out there at the panel, then it'll tell him to locate the panel. Once he locates the panel, then all of the 3D buttons and stuff will be superimposed on the panel. And so this is what he's gonna see right here. So what I want to do is I'm gonna click on one of them and I'm gonna show you how it's gonna operate. So let's say he got a problem with the door potential circuit. So he just hit this, and then it brings up the schematic.
Auxiliary
and then it bring up the talking forward also to tell you something about the circuit.
And the final application of power for the door. Operation. When the door is near the seal, the open limit switch is open and relays OD, TD, and DL are de-energized. Relay DL de-energizes immediately and de-energizes DP, cutting off the AC power to the door motor and applying DC braking to the door motors. Relay TD remains closed for about a second and then de-energizes, opening TD and closing TD. The opening of TD de-energizes TX, which will drop out about 1.2 seconds later. The closing of TD energizes DP through TX. T causes AC power to again flow to the door motors until TX drops out. TX also interrupts the holding circuit, and opening relay O is de-energized. During the final application of power, voltage is reduced by a resistor R1 in one line of the motor circuit, which becomes effective when relay DL is de-energized. The closing operation is similar with the constant energization of CR110, doors closed request from the PLC. Remember, TD5 is a normally open time open contact, line 118. TD6 is a normally closed time closed contact, line 125, and TX is a normally open time open contact, line 127.
Okay, and so see it comes back, and then we're gonna look at one more that's brief, and we'll see. Let's see, I'm just gonna pick one. Let's see, I picked the motor starter circuit. Motor circuit.
The M and RS relay circuit. This circuit is the motor protection reset relay circuit. It is responsible for removing power to the door motors if they are taking more than a minute or so to open or close to protect them. The following relays must be energized to start an open or close door process. CR102, doors reset request from PLC, line 167, and RS, motor protection reset relay, line 118. Here's the circuit operation. The motor protection time delay relay in line 129 should not be energized. Time contact M6 should be closed, line 118. CR102 coil is energized, line 167 from the PLC. As long as either the closed or open contacts in line 129 is closed, the process will be started. M will be energized and will give contact M6 about a minute before it drops out RS. Line 118, removing control power from line 124 down. de-energizing any relays that control the door motors. Remember, M6 contacts are normally closed, timed open.
Okay, and so that's what they'll be able to do. They'll be able to go through each one and see about the print. And they can always refer back to the actual manual that they have. So this gonna end this demonstration part right here, but I have another picture that I gotta show. So we're gonna take a break and then we'll come back and I'll show you what the actual lift looks like. Okay, now. Okay, so this is the actual lift right here that relay panel actually controls. It's 2 doors on the east side and 2 doors on the west side that it actually controls. It controls those doors on the first floor and when it gets up to the 4th floor. So you got dual panels on each floor. So let's see, what else I got here? Then you got some bar stops and stuff. It's got a lot of different controls that's actually on the lift itself, but these are the main controls that make the lift go up and down. So to facilitate time, I had to choose one of the circuits or one of the modules to do. And so this seemed like it was the most complicated one, dealing with the relay panel for the lift. So that's the one I chose. But eventually I end up doing each subsystem because it's got a subsystem that makes pins go out so it can ride on the pads. It's got another subsystem that's got the encoder to keep track of its position. It's got several other systems on it, but due to time constraints, I won't be able to do all those, so I just chose the relay panel to do it. So I appreciate you taking the time to look over the video, and have a nice day.